Okay, let's build a marketing mix model and compare it with our attribution data in Rockerbox. So this is a marketing mix model. You might not know what this means. It's an attribution method that can give you an alternative viewpoint on which channels are driving performance compared to what you'd see in your analytics or with an attribution method like Rockerbox. And the really cool thing you can do with Rockerbox is get all of your data in one place so that you can build this model and make the comparison. It used to take weeks of dev work to do this, and now you can do it in an afternoon, which is really great. So the way that the data comes out in Rockerbox is like this. As you can see, there are multiple entries for each date. There's multiple channels. This is tier 1 channels, tier 2 channels. And then you have the data-driven conversions or data-driven revenue, you have last touch revenue, etc. So this is this is the format the data comes in, but you can't build a model straight from this. You need to transform it. And typically this step is what takes a long time. Marketing mix modeling sometimes takes as long as 3 months to build a model if you have a really complex marketing mix. And a big portion of that is just like getting all this data. Cool. So if you have Rockerbox, you can use the Google Sheets sync in order to get the data out in this format. And then you're going to be able to bring all that together. So how do you get it from this format where you have multiple rows and then you have the different channels just compacted into these rows? How do you kind of unstack that and get it into tabular data, which is what you need for the model? So this is the analytical base table. This is the data that's in its cleanest form, ready for modeling. And in order to get this, we need to use pivot table. So the way that you create this pivot table is you literally just select all the data and then go to insert pivot table. And then you do a few different things to pull this in. So let me just show you how this works, just because this is the common area where you might get tripped up. Cool. So just going to click, just going to click anywhere in here and going to press Control A to select all the data, or you can press Command A. That's much quicker than dragging it all the way down for 600,000 rows or whatever it is that you have. So I'm going to go to Insert, Pivot Table, and then I'm going to put that into a new sheet. And now we're going to add the date as the rows. That's pretty straightforward. We're going to add the spend as the values, and you can see it's already kind of aggregated it, so that the sum of all the spend across all the channels is there by date now. That's what a pivot table does for you. Kind of pivot the data and aggregate it in different ways. Now we're going to add the tier 1. That's going to momentarily complain at you, but then it's going to come back and work fine. And then you're going to add the tier 2. And that's when it's going to break. So this is the problem with Google Sheets or Excel. So there's a limit on how many rows and columns you can have before it starts to run out of processing power. So this data set is an example data set which shows all the different marketing channels that you could have as an e-commerce. So this is an unrealistic data set, but your data set will probably be a little bit simpler. If it's not, then you probably need to consider outputting this data into BigQuery or another data warehouse where you can manipulate it at larger scale. But you should be able to do this, and definitely you can do this within the confines of this tutorial. So the way that I got this working is there's lots of organic variables in here, like lots of referral spend, referral traffic, things like that. That we're just going to ignore for the purposes of this demo. So what I'm going to do is going to click Add on the filters, add a spend filter, and then I'm going to go to Filter by Condition, greater than 0, and then hit OK. So what this is going to do is only give me my media channels, because we're showing the spend. And yeah, this is going to take a little bit of time to process. But we're showing the spend, but if we're only showing channels that have more than 0 spend, then that's our media spend. You can see that some of the channels have blank here, have blank days where we didn't spend, but then eventually that you do spend on those channels. Okay, so the other thing we need to do in order to get the data in the right format is when we bring it across into the base table, we need to do something like this. So you see this channel here where it has no spend. If I just bring that across, it's going to be blank. So the model is going to freak out when it sees that. What you need to do is you need to put it into an if statement. So you say if this is, this means not equal to blank, then you can go ahead and use this value. And that's fine. If it's not equal to blank, then just use that number. And if it is equal to blank, then we're going to put 0. And there we go. Now we have 0. And if we, either double click or drag that down, you can go all the way down to, row 600,000 or whatever it is. I don't think it's that much now. We'll be able to see. Yeah, here we go. So now we can see that some of the days we do have spend, and then most of the days we have 0. Okay, so yeah, it's come through here just fine. So that's the format it's going to be able to model in. So there should be no blank rows. Okay, so that's how I did this here. So I did the media spend, and then if you look at the analytical base table, I've done a similar function here. If this is not equal to blank, then use it, and then otherwise it's 0. I also did the revenue separately. So this is the same thing, except instead of spend, I brought in revenue, and that just needs to be one column because you're basically predicting, from all the spend, the spikes and dips in spend, how well does that predict whether the revenue goes up or not? So that's what the marketing mix model is doing. And the final thing I did to get this right is I did a pivot table of revenue based on last click. So this is exactly the same as the spend. We still have the filter, so I just made a copy of the media tab, but then just swapped out spend for revenue. And this is going to let us compare our attribution to modeled revenue at the end, which I'm going to show you. There's a couple more things I did in the template. One was I summed up the revenue. That's so we can compare it later on. And I also summed up the media spend for the channel and then found out what share that media spend was of the total pie. So, this channel, we spent 7% of our budget on impact radius. Cool. So now everything's together like that. That normally takes weeks or months in some cases, but now it's it's done pretty quickly. What we need to do now is feed that into the algorithm. So there's just one that you can use in Google Sheets. This is the linest function. It's pretty straightforward. You just pass in the revenue. This is column B in the ABT, the revenue. And then you pass in, that's what you're trying to predict, and then you pass in everything you're using to predict that as the second parameter. So this is C2 to AQ613. So that's all that rest of that data in the ABT. And what it's going to do is then crunch the numbers and tell you how much, based on the spikes and dips and the correlations, how much it thinks that each channel has driven in revenue. So that's what a marketing mix model is doing. This is the simplest algorithm, but you could actually, once it's in this format, you could actually run a Google app script to create to generate your own algorithm and use that instead. For example, you can use a Bayesian algorithm. That's like the most common kind of modern way to do it. There's also open source libraries like Meta Robin that you can use, or Uber has Orbit, Google has Lightweight MMM, and you can either do that as a Google app script, or you could kind of reference the analytical base table using the Google Sheets connector, or you could just go here and just download this as a CSV and kind of use that locally in your script. So you have a lot of options once you get the data into this format. Okay, so what are we looking at here? What does the marketing mix model tell us? We mentioned that the model is going to tell us what was the contribution of each channel to revenue, and that's what the coefficients are here. So in this scenario, it's saying that Tatari drove $10 of revenue, that's the predictor variable, for every $1 of spend, because we inputted spend and then it's giving us this value here. One thing you might notice straight away is that there's some pretty implausible values here. So for example, Spotify, it's saying that for every dollar we spent, we got negative $4 back in revenue. And this is a sign that the model isn't correctly specified. This is, the game, right? It takes a long time in some cases to find the right combination of variables to include. So, for example, some channels are very highly correlated with each other. You increase your, YouTube and your Spotify spend at the same time potentially, and therefore one will push out the other and steal credit from the other. It's very hard for the model to deal with that. So there are different statistical techniques you can use, and you can engineer features to join things together or control for them. You can also, like, this is just the media spend. It's also possible to control for different seasonality or organic variables, but you do have to be careful with that as well, because that can lead to its own problems. But once you have a model that looks plausible, you can tell its predictive power using this metric here, MAPE. This is the mean absolute percentage error. What this is saying is, on average, the model predicted the past data with only a 12% error either way. So you can see that visually. The gray line is very close to the blue line. It's following a lot of the spikes, even the really big spikes here. So that's really good to see. It means that the model is doing a decent job predicting past revenue. One thing that you would normally do with a model in production is use it to predict future revenue as well. So maybe hold back some of the spend and train the model on, say 80% of the data, 85% of the data, and then see if it can predict that last 15 to 20%. And if it can, then you know that the model hasn't overfit, and it's it's going to do well when it predicts future data, and you make your spending allocations that way. So a few other things to look at to tell whether the model is accurate. The p-values. This is a concept that everyone gets wrong, but generally, I'm not a statistician, but generally speaking, if the p-value is less than 0.05, that's a good indication that the model knows about that variable, and that the coefficients can be more trusted. That's not a guarantee, because like we said, a lot of channels are correlated with each other. So maybe, I don't know, Tatari pushed out TTD, and they were both spending at the same time, and therefore a lot of credit went to Tatari, and then TTD got a negative coefficient. So it's not necessarily true that if your p-value is good, then you can trust the result. There's a whole kind of online wealth of literature to dig into these specific issues, and it takes a long time to learn. But you typically want to work with an expert when you're doing this, just to make sure that the model is correct. The other thing to look at is like the percentage margin of error. If, again, all things being equal, it seems to know more about these two variables than it does about this one. This one has a pretty wild swing, 200%. This one's 172% swing. So it's saying it could be anywhere here between -6 and 1.6. So that's a pretty wide range, and therefore we would say that the model doesn't know that much about this channel. Could be because it doesn't have that much spend. Could be because it didn't have that much impact. Because this is a probabilistic method, it has to be able to tease that out. Cool. So when you add up all the contributions, that's what you get here. You can see, by and large, even though this looks a bit daunting, there's a lot of negative values here that don't look realistic. Actually, most of those negative values are relatively small contributions, relatively small channels. So they're not making a big difference to the overall predictive nature of the model, which is why you can have pretty good error, even though you have some implausible results. Now, you have to be careful with that, because if it doesn't know about the channels, and then those channels become more dominant in the future, then the error is going to grow pretty quickly. But yeah, by and large, you can see which channels are making a positive contribution, and make some changes based on that. Cool. One other thing to look at in terms of plausibility, this is the decomp RSSD. This is the metric that Meta made up for the Robin open source marketing mix modeling library. And what this tells you is basically the similarity between what the model tells you the effect share is, what the coefficients are, compared to what the model tells you, compared to what you were previously spending on those channels. So if you spent 80% of your budget on Spotify, but like the model is telling you that Spotify doesn't have an impact, then that would lead to a very bad decomp RSSD. If you're spending 10% of your budget on Spotify and it drove 10% of the revenue, then that would be a very good RSSD. So I say bad and good, but ultimately, you don't know what the real answer is, right? You're just trying to figure that out. Like the attribution of last click is flawed in some ways, but so is marketing mix model flawed in other ways. And this is just telling you how much they agree. But part of the job of the marketing mix model is to find scenarios where they don't agree. So it's a controversial method. I would say in general, though, you want the decomp RSSD to be as good as possible. And then if there are still differences, then you can trust those differences more. Cool. So that is the whole model. But the payoff for doing all this work is this thing here. This is the multiplier tab. And what this is going to tell you very plainly is how incremental or how decremental, if that's a word, each channel is. So in this scenario, we can see we have Facebook, Instagram, and that was reporting $29,000 total on the last click. And what this model is telling us is that actually, no, this channel seems to be responsible for $93,000 in revenue. Because when we spend more on the channel, revenue spikes. So that's really interesting. And this is the payoff. Like assuming the model is valid and you've gone through all the statistical checks and you've worked with someone who knows what they're doing, like a vendor like Recast, or you using the Meta Robin library with a data scientist in house. Once you've got the model working, you can make decisions based off it using these multipliers. So, for example, if you did find a result like this, when you're optimizing your Facebook campaigns, you're allocating budget, you can say, no, my ROI is not 134%. It's actually 646%. So Facebook is underreporting based on a last click basis. And that could be for a number of different reasons. One, for example, is iOS 14. Facebook used to claim too much credit, in my experience, but now it's actually not claiming enough credit because it's users can opt out of tracking on iOS, and therefore Facebook can't always track those users all the way through. So that has had a big impact on why that's why people are looking to these alternate methods like marketing mix modeling. The other reason is that Facebook drives a lot of view through conversions. So for example, if you're showing your ads to millions of people every day, some of those ads are going to remember. You're going to trigger memories for people, and they might not click on the ad, so they wouldn't be counted in last click, but they might search for your brand afterwards. So you notice the phenomenon that when you advertise a lot, then your brand searches go up, and then when you turn off ads, your brand searches go down. Well, marketing mix modeling is one way to kind of capture that and estimate that effect. Cool. So that's how that works. You can change it, here. So you can pick whatever channel you want and see the multipliers. Multiplier for Shopzilla is 4. You could also have a negative multiplier. So this is maybe a bad example, but yeah, you could have a multiplier where it says actually the channel is less incremental than you thought. So this is a scenario where the channel is maybe claiming more conversions than it really deserves. So if the multiplier was negative, that would mean that it's getting too much credit for the sales that it's supposedly driving, when actually it's other channels that are driving those sales. So for example, Google brand advertising campaigns, So when you're advertising on your brand keyword, that tends to be not very incremental, right? It's going to capture a lot of revenue because people click on that result. But if they're searching for your brand, then they must have heard about you from somewhere. So it probably, they came through from word of mouth, or they saw a Facebook ad or whatever it is. So rather than giving Google all the credit, you can work out how much credit Google actually deserves for those campaigns. Cool. All right, so that's how you build a marketing mix model. Obviously, there's and there's a lot of different caveats here. I've highlighted some of the common gotchas, but I would say that this method, marketing mix modeling, isn't for the faint of heart. Like, you do need someone who understands statistics and can spend some time working through the model. But if you're going to work with that person, they're going to need the data in this format. And if you can do that, you're going to save yourself a lot of time and effort and money, and make the job a lot easier for them. And the really cool thing you can do here is something that maybe wasn't done with traditional marketing mix modeling before we had all these fantastic tools. Is you can actually do an always on model. So you could build a marketing mix model that runs every day or every week if you want, because with data sync you can sync up the data so it keeps updating every day. So normally marketing mix modeling would be done like once or twice a year, or once a quarter, but now you can have it always on and always adjusting and recalibrating. So I think that's the really big payoff, and that's something that wasn't really possible, or definitely wasn't as easy 5-10 years ago. All right, hopefully this was useful. Let me know if you run into any issues or you have any questions. You can always reach out.